Hi guys, in today's video we're gonna see how we can use double integrals to find area of shapes, right? So we have our function, which is this one, and d is bounded by these two functions here, right? So first thing first, what we want to do is to sketch the graph, right? So we're gonna sketch the graph so that we have an idea of the region bounded by these two functions. So first, y is equal to x cubed is a shape like this that goes like this, right? Now y is equal to square root of x is a shape like this, but so we don't need the negative part. So by the way, my bad, y is equal to square root of x. The curve here is something like this. Yeah, my bad. Our region is basically, so we can write the equation. So this is y is equal to x cubed, and this one is y is equal to square root of x, right? So we want the area of this part here. So we want the area of this, yeah? So this area, the x, this is 0, so our x goes from 0 to this point, right? That we have to find. So we can find this point by doing the simultaneous equation between these two, right? So if we do that, so we have y is equal to x cubed and y is equal to square root of x, and this implies that square root of x is equal to x cubed. Now if we square both sides, we're gonna have that x is equal to x to the 6, and then we're gonna move x on the right hand side by changing the sign. So we have x6 minus x is equal to 0, and then if we factorize, this implies that x times x5 minus 1 is equal to 0. Now we're gonna have that x is equal to 0, which is this point here, which is this one. And now as you can see here, when x is equal to 1, this is also solution of the equation. So we have x is equal to 1. So this point here is 1, right? So x goes from 0 to 1. We have the x part. Now for the y part, we have to consider this, right? So we can say that y is greater or equal to x cubed in this case. So we have y greater or equal to x cubed. Now for the function y is equal to square root of x, we're considering this, right? So we have y less or equal to square root of x, right? So we have y less or equal to square root of x. If we combine these two, we're gonna have that y is less or equal to square root of x, and y is greater or equal to x cubed, right? So our y is this. So we have our x and we have our y. So now we can write our double integral, right? This is the double integral from 0 to 1, and for the y, as you can see, y goes, so x goes from 0 to 1. Now our y goes from x cubed to square root of x. So we have y goes from x cubed to square root of x, and then we write our function, which was this one here, right? So you can copy and paste it here. and then as you can see, this is gonna be dy and then dx, right? Now we can solve it. Our integral, this is gonna be, so first we're gonna do the first part, which is the integral with respect to y. Let me duplicate. So first let's do the integral with respect to y, right? So this is gonna be equal to, since we integrating with respect to y, everything behind the y, so in this case the 4x is gonna be a constant, right? So this is gonna be 4x, and then we integrate the y, which is y squared over 2, and then that goes from x cubed to square root of x. Now minus, here we have a y, so this is gonna be y4 over 4, and then goes from x cubed to square root of x. Now this is equal to 4x, and then we substitute this into our y squared over 2, so we're gonna have square root of x. If we square it, we're gonna have only x left over 2, and then minus, we substitute this one inside, so we have x cubed to the power 2, which is x to the power 6 over 2, right? And then minus, we do the same here, we substitute this inside, we have square root of x to the power 4 is gonna be x squared over 4, and then minus x cubed to the power 4, which is x12, right, over 4, and this gives us 4 over 2 is 2, so 2x squared, and then minus 4 over 2 is 2x7, and then minus x to the power 2 over 4, and then plus x to the power 12 over 4, right? We have here x squared, we can add them up, and that gives us, this is equal to x to the power 12 over 4, and then we have minus 2x to the power 7, and then if we add 2 and minus 1 over 4 plus 7 over 4 x squared, right? Now this is the integral with respect to y, but we have the integral with respect to x left, right? So we're gonna do integral from 0 to 1 of what we found here, and then this is gonna be with respect to x. So now we have to do the integral with respect to x, and that is equal to, here 1 over 4 goes out, which is the constant of this, and then we have the integral x to the power 13 over 13, that goes from 0 to 1, and then we have minus 2 out, we do the same, x to the power 8 over 8, that goes from 0 to 1, and then plus 7 over 4 x over 3, that goes from 0 to 1, and that is equal to 1/4 times, here if we substitute 1, it's gonna be 1 over 13 minus 0, we can close the bracket, and then we have minus 2, same thing, times 1 over 8, we close, and then plus 7 over 4 times 1 over 3, and that is equal to 55 over 156, and that is the area that we were interested in.